Here, this section we have infinite series. The first part, definitions. Here on this part we have sequence. So given a sequence of numbers a sub n, an expression of the form a sub 1 plus a sub 2 plus a sub 3 plus 3 dots plus a sub n plus 3 dots is infinite series. So here we have 3 dots. That means that here on this part we have infinite series. The number a sub n is nth term of the series. The sequence s sub n defined by, so here we have s sub 1 that is equal to a sub 1, s sub 2 that is equal to a sub 1 plus a sub 2. So here we have these two terms for s sub 2, 3 dots s sub n. Here we have n terms starting from a sub 1 up to a sub n. Adding all these, that is equal to, this sign is for sum, so this is sum, and that is from k equal to 1, so k equal to 1, k equal to 2, k equal to n. So here we have k equal to 1 up to, when we have this point, up to n. So sum of a sub k, k from 1 to n. That is the sequence of partial sums of the series. The number s sub n being the nth partial sum. If the sequence of partial sums converges to limit L, we say that the series converges and that its sum is L. In this case, we also write a sub 1 plus a sub 2 plus 3 dots plus a sub n plus 3 dots, that is equal to sum of a sub n, n from 1 to infinite, and that is equal to L. So sum is equal to L. If the sequence of partial sums of the series doesn't converge, we say that the series diverges. So if it doesn't converge, that means that diverges. So here on this case, we have a sub n, and that is from 1 to 6 this point. So the sum of a series with positive terms can be interpreted as a total area of an infinite collection of rectangles. So here we have rectangles for each one of these terms. The series converges when the total area of the rectangles is finite, and diverges when the total area is unbounded. Now here in part B, again we have these terms starting from a sub 1 up to a sub 6. Note that the total area can be infinite even if the area of rectangles is decreasing. So area of rectangles decreasing. If absolute value of r less than 1, the geometric series a plus a times r plus a times r squared plus 3 dots plus a times r power n minus 1 plus 3 dots converges to a divided by 1 minus r. And sum of a times r power n minus 1, n is from 1 to infinite, that is equal to a divided by 1 minus r. So what we had here on this part, sum of that term from n equal to 1 to infinite is equal to what we have here on this part. And absolute value of r is less than 1. If absolute value of r greater than or equal to 1, the series diverges. If sum of a sub n, n from 1 to infinite converges, then a sub n approaches to 0. The n term test for divergence. Sum of a sub n, n from 1 to infinite diverges if limit of a sub n, n approaches to infinite fails to exist or is different from 0. So if failed to exist or different from 0, that means that sum of a sub n diverges. Theorem 8, if sum of a sub n equal to a and sum of b sub n equal to b are convergent series, then number 1, what we have for sum rule, that is sum of adding these two, a sub n plus b sub n, that is equal to sum of a sub n plus sum of b sub n, and what was given on this part, we have a and b, so that is equal to a plus b. Number 2, difference rule. So here on this part, we have to subtract. So sum of a sub n minus b sub n, that is equal to sum of a sub n minus sum of b sub n, and that is equal to a minus b. Constant multiple rule. Sum of k times a sub n, that is equal to, moving this one to the left side of sum, so we have k times sum of a sub n, and that is equal to k times what we have for sum of a sub n based on what is given here on this part, that is a. So this is equal to k times a, and k is any number. Every non-zero constant multiple of a divergent series diverges. And what we have here on this part, if sum of a sub n converges and sum of b sub n diverges, then sum of a sub n plus b sub n and sum of a sub n minus b sub n would diverge. So if you had one of these diverge, that means that sum or difference is, again, same result, is diverge. So it doesn't matter if one is converged, the other one is diverge. Adding, subtracting, you're going to have diverge. Example, write up the first few terms of the series. Sum of 2 divided by 3 power n plus negative 1 to the n power divided by 4 to the n power, and n is from 0 to infinite. What is the series sum? Evaluate the first term, which is a sub 0, that is equal to, using what we have here on this part, 2 divided by 3, instead of n we have 0, plus negative 1, instead of n here we have 0, divided by 4 power 0. So this is equal to 2 divided by 3 power 0, that is equal to 1, plus here again power is 0. It doesn't matter what we have for base. If your power was 0, the answer will be 1, and that is same for denominator. We have 4 power 0, so again we have 1. So the final answer on this part, we have 2 plus 1, that is equal to 3. Now evaluate the second term, which is a sub 1. So here in this case, instead of n, now use 1. So it's equal to 2 divided by 3 power 1 plus negative 1 power 1 divided by 4, again power 1. So we have 2/3 plus negative 1 over 4. So denominator is 12. 12 divided by 3 is 4. 4 times 2, we have 8. Again, 12 divided by 4 is 3. 3 times negative 1 is negative 3. So adding what we have here on top, we have 8 plus negative 3, so that is 5 divided by 12. So the answer is 5 over 12. Now evaluate a sub 2, that is equal to 2 over 3 squared plus negative 1 squared over 4 squared. So this is equal to 2 over 9 plus 1 over 16. Simplify, so denominator we have 144. And numerator we have 32 plus 9, and that is equal to 41. So the answer for the a sub 2 is equal to 41 over 144. Now a sub 3, that is equal to 2 over 3 cubed plus negative 1 cubed divided by 4 cubed. So that is equal to 2 over 27 plus negative 1 over 64. So the answer for a sub 3, that is equal to 101 divided by 1728. The given series is equal to sum of the first part 2 over 3 to the n power, n is from 0 to infinite, plus the second part, sum of negative 1 to the n power divided by 4 to the n power, n is from 0 to infinite. So now this is equal to sum of 2 times 1/3 to the n power. So I moved this here and I used 2 times 1. We have here numerator 1 over 3, and then use this power for both numerator and denominator, plus the same thing and second part, sum of, here we have n and here we have n, so same power, so use that power for numerator denominator. We have negative 1/4 to the n power. So what we have here on this part, sum of 2 times 1/3 to the n power, n from 0 to infinite, that is geometric series with a equal to 2 and r sub a is equal to 1/3. Since absolute value of r sub a is less than 1, so what we have here is absolute value of 1/3, so that is equal to 1/3, and it's less than 1, this series converges. Sum of this series is given by s sub a equal to a over 1 minus r. A is 2, r is 1/3. So I'll simplify. The answer is equal to 3 for s sub a. And that is sum for first part. And then second part, that is what we have here. So the sum of this series is given by s sub a equal to a over 1 minus r. In this case, what we have here outside, that is equal to 1. So we have 1 times negative 1/4 to the n power. So what we have here inside, having power, this one is negative 1/4, that is r. So we have 1 over 1 minus r is negative 1 over 4. So this is equal to 1 divided by 1 plus 1/4. So simplifying, the answer is equal to 4 divided by 5. This means that what we have for final answer, sum of the series is equal to 3 plus 4 over 5. The final answer is 19 over 5. Example, find a formula for the n partial sum of the series and use to determine if the series converges or diverges. If the series converges, find the sum. So what is given here on the spot, we have sum of 3 over n minus 3 over n plus 1, n is from 1 to infinite. So here on the spot, I used s of n for sum of the first n terms of the series. So s of 1 is equal to 3 over 1 minus 3 over 1 plus 1, so that is 3 over 1 minus 3 over 2. And s of 2 is equal to what we have for s of 1 plus, here instead of n, now use 2, so we have 3 over 2 minus 3 over 2 plus 1, so that is 3 over 3. So continue this process, and what we have here for s of n, that is equal to, using what we have for s of 1, then what we have for s of 2 with the first two parts. This part is for s of 3, and then this part is for s of n minus 1, and here we have what we have for s of n. So on top, for all of these, we have 3, and denominator we have 1, add 1 we have 2, we have 2, add 1 we have 3, again use that one. Here on this board we have 3, and then add 1 we have 4, and here for s of n minus 1, starting what we have is n minus 1, and then add 1 we have n, use that. Here on this part we have n, then add 1, we're gonna have n plus 1. So add, subtract all these that we have for s of n, simplify. So here this part 0, this part adding these to 0, here what we have after, we're going to have negative 3 over 4 plus 3 over 4, so that was 0. And what we have before this part, we have negative 3 divided by n minus 1, so that was 0. Negative 3 over n plus 3 over n, that is 0. So what's left is the first and the last part. So s of n is equal to 3 minus 3 over n plus 1. Now evaluate limit of s of n as n approaches infinite. So that is equal to limit of 3 minus 3 over n plus 1. So if we use infinite here, instead of n, we're going to have 3 over infinite, and that is, this part will be 0. So this is equal to, this limit is equal to 3. So therefore, sum of 3 over n minus 3 over n plus 1, and from 0 to infinite, this was what we had on top, this part was given, that converges and has a sum equal to 3. Find the sum of series, sum of 3 over 3n minus 2 times 3n plus 1, and from 1 to infinite. Using partial fraction, 3 over 3n minus 2 times 3n plus 1, that is equal to a divided by 3n minus 2 plus b over 3n plus 1. Multiply both sides by 3n minus 2 times 3n plus 1. And then simplify, we're going to have 3 equal to a times 3n plus 1 plus b times 3n minus 2. And then I used distributed properties of a times 3n, a times 1, b times 3n, b times negative 2. So we have 3 equal to 3an plus a plus 3bn minus 2b. Now solve for a and b. So here on this part we have like terms, here we have n, here we have n. On this side, on left side, we do not have n, so that part is 0. Plus what we have here on this part, it's without having n, so that is a, and here is negative 2b. So use these two terms equal to, on left side, this is the part that we don't have n, so that part will be equal to 3. So solving for a, b, we have, using this one, 3a plus what we have for coefficient of n, on this part we have 3b equal to, on this side we have 0 times n. We don't have anything on this part, that means we have 0 times n, so this is equal to 0. And then what's left, here we have a, here we have negative 2b, and that is equal to what we have here on left side, it is 3. So here we have system of two equations with two variables. Solving a and b, here I multiply the second part, the second equation by negative 3. So we have to rewrite the first one, 3a plus 3b equal to 0, and the second part times negative 3, we have negative 3a plus 6b equal to negative 9. Now add, so here this part cancels, and adding these two we have 9b, adding these two we have that equal to negative 9. So solving for b, b is equal to negative 1, and then use negative 1 in one of these two equations and find a. So I'm going to use the second equation, a minus 2b equal to 3, and b is negative 1, so a minus 2 times negative 1 equal to 3, a plus 2 equal to 3, a is equal to 3 minus 2, so that is equal to 1. Now substitute the values for a and b to obtain what we have for sum. So this is equal to sum of 1, so a is 1. So here on this part we have 1 over 3n minus 2, and b was negative 1, so we have minus 1 over 3n plus 1, and this is from 1 to infinite. So n is from 1 to infinite. Now write the partial sum s sub k. So the first part, this is s1, meaning that n is equal to 1. So here on this part we have 3 times 1 minus 2, it is 1. 3 times 1 plus 1, we have 4. So this is 1 over 1 minus 1 over 4. Then this part is s sub 2. So we have n equal to 2. We have 3 times 2 minus 2. Here we have 4. 3 times 2 plus 1, we have 7. Continue this process. What we have here is 1 over 7. Use the same number here on this part. And then for this line, we had to use n equal to 3. So we have 3 times 3 minus 2, it is 7. 3 times 3 plus 1, it is 10. And then for this part, I use n equal to k. So it's 3 times k minus 2 and 3 times k plus 1. So removing these parentheses and then simplify what we have for s of k is equal to 1 minus 1 over 3 times k plus 1. So these cancels. And what's left at the first and the last part. So find the limit of s of k as k approaches infinite. That is equal to a limit of 1 minus 1 over 3 times k minus 1. K approaches to infinite, that is equal to 1. So this part, having infinite in the denominator, we're going to have 1 over infinite, so that part is 0. We have 1 minus 0, so this is equal to 1. And what that means, sum of 3 over 3n minus 2 times 3n plus 1, and from 1 to infinite converges and has the sum 1. Determine whether the series sum 4 to the n power minus 3 to the n power divided by 5 to the n power n from 0 to infinite converges or diverges. If it converges, find its sum. So this series is equal to sum of 4 over 5 to the n power n is from 0 to n minus sum of 3 over 5 to the n power n is from 0 to n. Compare the series sum of 4 over 5 to the n power with general series a plus a times r plus a times r squared plus a times r cubed plus 3 dots plus a times r to the n power plus 3 dots. Divide a sub 0, meaning that we have to use 0 for n. So a sub 0 is equal to 4 over 5. Instead of n, use 0. So this is equal to 1. And then finding a sub 1, that is equal to 4 over 5. Power is 1. So n is equal to 1. So here in this case, power 1, and a sub 1 is equal to 4 over 5. The series converges if absolute value of r less than 1, and the sum of the series s is given by a over 1 minus r. In this case, what we have for r is 4 over 5, because of having this number less than 1, so 4 over 5 less than 1, the series converges. And then finding sum, s is equal to a over 1 minus r. A is 1, r is 4 over 5. Simplify, what we have for sum is equal to 5. So repeat this process for a second part. So compare the series sum of 3 over 5 to the n power n from 0 to infinite with the general series a plus a times r plus a times r squared plus a times r cubed plus 3 dots plus a times r to the n power plus 3 dots. So finding a sub 0, for this part we have n equal to 0. So a sub 0 is equal to 3/5. Power 0, that is equal to 1. A sub 1 is equal to 3 over 5. Power 1, so in this case n is equal to 1. So a sub 1 is equal to 3 over 5. So this series converges if absolute value of r less than 1, and sum of the series s is given by a divided by 1 minus r. So what we have in this case, r is equal to 3 over 5, and 3 over 5 is less than 1. So the series converges, and finding sum s is equal to a over 1 minus r. A is 1, r is 3 over 5, so we have 1 over 1 minus 3 over 5. Simplify, sum is equal to 5 over 2. So based on what we had for the first and second part, this is equal to sum of 4 over 5 to the nth power is equal to 5. And then subtract what we have on the second part, sum of 3 over 5 to the nth power, that is equal to 5 over 2. So simplify, the answer is 5 over 2 for sum.